This question says, how many significant figures are in each of the following measurements? And then we have a bunch of measurements. So essentially, any digit in a measurement, and these are all measurements because they have units, that's not 0 is definitely significant. If you have a 0 in a measurement, you want to identify whether that is a placeholder. And placeholder zeros are not significant. One of the easiest ways to determine if a 0 is a placeholder is if the 0 is after both a significant figure and a decimal place. It is significant. It doesn't matter if the decimal place comes first or if the significant figure comes first. And if a 0 is sandwiched between two significant figures, then it is significant. Remember, significant figures in measurements are any number that is not 0. And sometimes 0 in those two cases I said below, which are if it's sandwiched between two significant figures or if it's after both a number and a decimal place. So let's look at this. So what we have here is a decimal place. So we have this 0 out here. That's not after anything. It's not after a decimal place. It's not after a sig fig. This is definitely not a significant 0. Then we have these two, and then we have this one. So these are definitely significant. So let's take a look. We have 0.00. These zeros are after a decimal place, but they're not after any sig fig. There's no sig fig here. There's no sig fig here. So none of these three zeros are significant. Now let's look at this one. Now we have 2, 1, 0. So these are definitely significant. Let's look at this 0. It's after sig figs and a decimal place, so it is not a placeholder. So in this case, there are three significant figures. 86.0. These are definitely significant. Let's look at this one. We have this 0 after sig figs and a decimal place. Notice that in this example, the sig figs came first and then the decimal place. In this example, the decimal place came first and then the sig figs. It doesn't matter, okay? If the 0 is after both a decimal place and sig figs, whether the decimal place comes first or the sig figs comes first, no difference. This is also three significant figures. Let's look at this one. So this 0 is not after anything. It doesn't count. Let's look at these. These are only after a decimal place, not after a sig fig. Therefore, they're not significant. Now we have 5001. These zeros are sandwiched between two sig figs. They're also after both the decimal place and a sig fig, but for either reason, they're significant, and this is 4. You will never have a case where you don't have continuous significant figures. So there'll never be this 5 is significant and this 1 is significant and the zeros in between are not. All right? Because sandwich zeros are always significant. Therefore, you're always going to have continuous significant figures. Let's look at this one. This is scientific notation. Scientific notation makes it easy because the number out here is always between 1 and 9.9. So therefore, here you just count the figures. 1, 2, 3, 4. They're all significant. Because this number has to be a significant figure, because it has to be between 1 and 9.99. It can't be 0. Therefore, any number after the decimal point is significant. In this case, this is 4 significant figures. Also notice that the exponent makes no difference. The exponent has nothing to do with significant figures. All the sig figs are in the coefficient. So in this case, 4 sig figs. Now we have an example 200.0. In this case, this 0 is after both a number, the 2, and a decimal place, so this is significant. Note that when this is significant, these become sandwich zeros and are also significant. So you can never have non-continuous sig figs, just like in this example. All 4 of these are significant because as soon as this 0 is significant, these zeros are sandwiched, and therefore you have 4 significant figures. So really, when it's about significant figures, what you're really looking at is the zeros, because all the other numbers in a measurement are not significant. So that's what's important. Also note that not everything is a measurement. Something might be in a definition, like 1,000 milliliters equals 1 liter, or something might be simply counted. There are 12 hats on the shelf. That's not a measurement. That's just a counted number. There's no significant figures in counted numbers, and there's no significant figures in definitions as well.